It's kind of helpful to think of your body's chemistry less like a boring textbook diagram and more like a huge, bustling highway system. There's traffic flowing 24/7. So today, we're going to take a deep dive into what happens when that system gets a major traffic jam, right down at the cellular level.
So really think about this for a second. Picture the worst gridlock you've ever seen. Bumper-to-bumper cars, everything at a standstill. Now imagine that same chaos happening millions of times a second, but inside your own cells. It sounds crazy, but that's exactly the kind of situation we're talking about today.
And right at the center of this potential traffic nightmare is a molecule called homocysteine. Now, it's not the bad guy here, not at all. Think of it more like a car that's just arrived at a really critical intersection. It just needs clear signals and open roads to get where it's supposed to go. But when it doesn't, well, that's when things start to back up.
So what exactly is homocysteine? Well, scientifically, it's a type of amino acid. But here's the really important part. You don't actually eat it. Your body makes it. It's a temporary pit stop, or a byproduct, that happens when your body processes another amino acid called methionine. That's the one you get from foods like meat and dairy. The word to really lock onto here is temporary. Homocysteine is not meant to hang around.
All right, so if it's just a temporary stop, where is it supposed to be going? Well, the body has two major, super efficient highways designed specifically to clear it out. Let's take a look at these main routes.
Okay, highway number 1 is all about recycling. It's called the remethylation pathway, and its job is to turn that homocysteine right back into methionine, which is super useful. Highway number 2 is about conversion. This is the transsulfuration pathway, and it transforms homocysteine into something new, cysteine. And cysteine is a building block for glutathione, our body's master antioxidant. This stuff is a huge deal for protecting our cells. So you have two different destinations, both incredibly important.
Of course, these highways don't run on magic. They need the right kind of fuel to keep traffic moving. As you can see here, that recycling pathway, it absolutely depends on vitamin B12 and folate, which is B9. And the conversion pathway, that one needs vitamin B6. You can really think of these B vitamins as the high-octane fuel for our entire metabolic traffic system. Without them, everything just slows to a crawl.
But what happens if those main highways are all jammed up? Maybe because of genetics, or maybe we're just low on fuel. Well, our body, in its infinite wisdom, has this brilliant backup plan, a secret backdoor detour.
And this is basically the body's strategy, right? When the main road is a parking lot, it finds a clever workaround. It's smart enough to just bypass the traffic jam entirely, but only if it has the right tools for the job.
So this little detour has a fancy scientific name, of course. It's called the BHMT pathway, and its job is pretty much the same as that first highway: recycle homocysteine back into methionine. But, and this is key, it uses a different set of what are called methyl donors. You can just think of those as the little chemical tags that are needed to make the whole conversion happen.
So what fuels this alternate route? Well, it's mainly two key nutrients: choline, which you'll find in things like egg yolks, and betaine, which is packed into foods like beets and spinach. Zinc also plays a really important supporting role here. What this means is that your diet can literally open up a whole new road for your body to clear this stuff out.
Okay, so we've got these brilliant main roads, we've got this clever detour, so why do traffic jams even happen? What's causing the gridlock that makes homocysteine levels start to creep up in the first place? Well, a lot of the time, the roadblock is just a simple fuel shortage, not enough of those B vitamins we keep talking about. For some people, it's genetic. Variations in genes like the well-known MTHFR gene can mean their highways were kind of built with a few potholes from the get-go. And for others, the problem is absorption, or just lifestyle choices that throw a huge wrench in the works. Let's zoom in on B12 for a second, because its journey is, well, it's a little special. See, it's not enough to just eat it. For your body to actually get and use the B12 you eat, a special protein made in your stomach called intrinsic factor has to physically grab onto it. It's like a special key. Only when they're paired up can your body actually absorb them.
And this is so crucial. It means that if your body doesn't make enough of that intrinsic factor, which can happen for a lot of reasons like aging or digestive issues, then it literally does not matter how much B12 you eat. The fuel truck gets stuck at the station. It can't even get onto the highway. It creates a massive roadblock right at the very beginning.
Now, I know this might all sound a little complicated, maybe a bit out of your hands, but here's the most empowering part of this whole story. You are the traffic controller.
you have a surprising amount of influence over how smoothly this entire system runs, and a lot of it comes down to just managing your internal environment.
And you have to hear this concept because it is a game changer. Stress is a methylation thief. What does that mean? It means stress isn't just a feeling. It's a biochemical process that literally steals the resources, these little things called methyl groups, that your body needs to keep those homocysteine highways clear.
Let's break that down even more. When you're stressed out, in that fight or flight state, your body is diverting those valuable methyl groups to make stress hormones like cortisol. It's all hands on deck for the emergency. But when you're calm, in a rest and digest state, those exact same resources are freed up to be used for recycling, for repair, for detoxification. You are physically shifting your body's resources from one job to another.
And this is where it gets really cool, because this means simple behaviors can send incredibly powerful signals to your body. Just getting some morning sunlight acts like a metronome, setting your whole metabolic rhythm for the day. A short walk after a meal helps manage insulin, which protects those precious methyl groups. And a simple breathing exercise before you go to sleep, that's a direct command to your nervous system to shift into that rest and digest mode, maximizing all that overnight repair work.
So there you have it. You know the main highways, you know about the secret backdoor detour, and you know what causes the traffic jams. But more importantly, you know that simple things, from the food on your plate to the way you breathe, can act as your own personal traffic control system. So, the only question left is, how are you going to manage yours?